Okay, 1-6 today, guys. Okay, a determinant allows us to find, in our case, what is a determinant? I tried to do some research. What overall, just a value?
Well, okay, there is this official definition of a determinant, which you'll work, I mean, it's
More than linear algebra, right?
intuitive, and it goes way back when. But it's a number essentially that you compute based on the numbers inside the matrix.
Yeah.
And it has to be a square matrix for everything to compute. So yeah, it's
It's
basically a number.
basically a number, but that number is then going to help us solve how to find X and Y at the end of the day. Well, if they ask you. It also tells you whether the matrix has an inverse, because remember not all matrices have an inverse. Because if the determinant comes out to be 0, it would not have an inverse. Okay. So it helps you with that. You did see the determinant already, because I need you guys with me, please. Okay. So when we did a 2x2, A, B, C, D, we found its inverse, correct? How did we find its inverse? 1 over AB minus BC. And then we went B, A, negative B, negative A. Right? This right here, ladies and gentlemen, is the determinant of a 2x2. Right? No, just that. Now, that determinant can then help us out. But as Joe said back there, it does have to be a square matrix. So, if I had a 1 by 1, 1 by 1, so let's say 3, what's the determinant of this matrix? A. It would be 3. How are you? Okay. If I had a 2 by 2, okay, if I had a 2 by 2, let's say I had a matrix. By the way, I'm going to show you how we know. So if I had 1, 2, 3, 4, and as we already saw, it was basically A, B minus E. I'm going to show you the reason why in just a second. Why it comes from this. Notice that would have been 4 minus 6. So in this case, our determinant is negative 2. And by the way, we denote, or we put down, if I call this matrix A, and I want you to find the determinant, there's two different ways you could see it. You could say the determinant of A, you could see it that way. Or, kind of like the absolute value. Okay? Please understand this notation. Because sometimes they just have find this, and then people are like, what do I do? It's telling you what to do. Right? These bars represent determinant. Okay, so I can either see it that way, or I can see it a like absolute value of A, you know, that determinant. Now let me show you why it works. Okay, so every matrix, we're going to go ahead and we can use any row or column that we want. I personally am going to use this row. 1. Okay. So what I do is I take the number 1 and 2, and then I eliminate everything out of the row and the column for that 1. Okay? So basically, I'm getting rid of that row, that column, so who's left over? 4. And then I'm going to find the determinant of that. What's the determinant of 4? 4 times 1, 4. And notice we already had that up here. Notice we had 4 and minus 6. Well, let's see this 2 right there. Let's do the determinant. So we find the row and the column. Who's left over? 3. So 2 times 3, 6. Now, where does the minus come from? That's the tricky part. Okay? So therefore, that's the negative 2. Well, what we do is we call these minors and cofactors. Okay? So, excuse me. We're getting better. Not great, but better. On the old breathing front. Okay? But minors and cofactors. So if I said using a minor 1, 2, hi, Steph North. Sure, I'm a big fella. What is it? Awesome. You already did. And what else did you always do? Cookie and some water. You are so kind. Thank you.
I'm good. I'm
You
good.
you
I'm
sure?
good. Yeah.
No,
No,
you
I'm
did.
good.
Totally did.
Cut back. Cut back.
Look what's in here, Joe. We got, when you see this, you're gonna say, okay, I'll have it. A funnel cake. Where's the called?
Oh, this is from start.
You have Coach Star?
Yeah, well, we did a pro.
Yeah. And our Coach Star is getting national 5 years in a row. I know you guys are good. And, dog, bring the potato salad, down the way.
I may work on that.
Okay.
That does look pretty good.
Okay. That's what I had for lunch myself.
Oh, is it? Okay, we already have it.
Good.
Thanks, sir.
So once again, this says the minor, and then we come back up, what do we have? 1, 2, 3, 4. So what that means is first row, second column. So I take that 2, okay? There's the number, and then eliminate the row and the column, who's left over? 3. Now 6. Now, how do I get this minus? Well, each of these parts have elements. This is element 1, 1. Like if I call this matrix, say that's A1, 1, right? A1, 2, A2, 1, A2, 2. Is everybody with me there? Okay, and where this actually comes from is by doing this notation. -1 of the spot where it's at. So in my case, 1 plus 1, what's 1 plus 1? Of course. Right. 2. -1 squared is 1, so it's just whatever he is. But in this case, if I'm at -1, 1 plus 2, that is -1 to the third, which is -1, right? He's going to be a -2. So you have to put the value here. Now, when you get to different matrices, so if I had just a regular 1 by 1, I'd just have a plus. If I had a 2 by 2, I'd have plus, minus, minus, plus. Because notice that's 1 plus 1 is 2, -1 squared is 1. 1 plus 2 is 3, -1 cubed is -2. So -1 cubed is -1. This is 2, 1, right? 2 plus 1 is 3, -1 cubed is negative. 2 plus 2 is 4, -1 to the 4th. Does that make sense where these are coming from? How about a 3 by 3? What do you guys think? What do you guys think would go? Plus, minus, plus, minus, plus, minus, plus, minus, plus. And that really does come from the power. This notation is 3 power 1. When I add that together, 3, 1 is 4, -1 to the 4th is positive 1. Does that make sense? Okay, everybody there with me? But as we said, we could quickly, on a 2 by 2, just do our 1 times 4 minus 2 times 3 to give us 4 minus 6, which is -2. Okay? Now that number will come back later to help us solve a system of equations. Okay? Framework. Now I don't know what the test looks like. No one ever want to see it. But if I was writing the test, I still never have framework on. So I'm pretty
It's there, don't worry.
I'm pretty sure you do it. Now, with understanding this, guess how many times now, guys, we've learned how to do a system of equations? Technically 5. We've done just our elimination that we learned back in the day, right? Then we did reduced echelon form, which is Gauss elimination. Gauss elimination. Then we have reduced row echelon form, which is I think right now Gaussian Jordan. There's 3. Then we did our matrix equation in times dividing inverse, which we did last time. Right? That's 4. And we're going to show Kramer's rule, which is 5, which helps us with our determinant. Okay. All right, so now let's go ahead. We found it pretty easy with the 2 by 2. Nothing too hard on that, right? Okay. On a 3 by 3, let's go ahead. I found that one to be quite easy, so I'm going to pick another one. Okay, so remember, it goes in that form. We'll look at it. Give me just on a 2 by 2, yes. It will be always the subtraction. And the reason being is, once again, we have A, B, C, D, right? If I pick the row, which row do you want to pick? A, B, C, D, or column A, C, D, B? You choose. You want to pick row C, D, okay? So if I was going off of that and I was finding my determinant, now once again, this is the long way. I would not do this, but normally our determinant is just AB minus the B. Okay? But if I'm picking this row, okay, and I'm picking CD, so I'd have C and I'd have D. Now, remember, this is the plus minus, what's this one? Minus plus, right? So in front of C, I'd have my negative, and in front of D, I'd have my positive. Okay, so remember, then I would eliminate the row and column C is in. Who's left over? B. And I'd find the determinant, which is just B, so that's negative BC. Okay, and then I use D. Get rid of the column and the row. What's left over? A. So that's D times A, or AB. That's your question? No, you said you have a headache. I understand. Okay, so I'm going to write a matrix, and I sure the hell hope it's going to have. You're good. I sure the heck hope it's going to come out with a determinant not 0. Okay, so let's do this. 1, negative 2, 3, 4, negative 1, negative 2, 5, 1, 6. Okay? I just made this matrix. I'm going to call him A. I didn't even look in the book. I sure the heck hope this sucker has not a determinant of 0. Because if it has a determinant of 0, what that could tell us is that it would not have an inverse. Right? All right. So now I have a 3 by 3. Nothing's happening right now. I'm not told to do anything. This is just a matrix just floating here. Okay? But as soon as I do this, or this, that tells me to do something. I'm going to then find the determinant of that matrix. Okay? 3 by 3 is just a slight bit different. Did anybody write that down for me? I'm sorry, I forgot to copy it down. So remember, that's what the absolute value E bars would look like. That means determinant. Okay? 1, 2, 3, 4, 1, 5. All right. Now, that's what that means. Is the absolute value might mean determinant. It doesn't mean absolute value. In a matrix, that means finding the determinant. So if they said find, and then they had a matrix with the absolute value things around them, it means you need to find the determinant. Okay? All right. So I need to go ahead and find a row or a column. It doesn't matter which row or it doesn't matter which column I do. Okay? But what we're going to break this down is into 2 by 2 with scalars out front. Kind of in a way, not scalars or factors or something like that. Okay? Anyway, just tell me a row. So we either got a row or a column. Tell me one of them. I don't know. Huh? Use column 1 or row 1? So he wants to use row 1. Okay? We're going to do this 2 ways. We're going to use row 1, and then maybe we use column 2 for the second time. And see if we get the same determinant. We should be able to get the same determinant. Okay? Everybody with me? Okay. So what we do is we write these numbers. 1, negative 2, 3. If you recall, what did I do on my 2 by 2 to really show you what that formula came by? Remember, I eliminated the column and the row it was in and found the determinant of the leftover. Do I know how to find the determinant of a 2 by 2? So this is what's left over. Negative 1, negative 2, 1, 6. Go down to a 3 by 3 and we need to do those again. All the hymn going. Pain in the butt. I'm sorry, say again. Okay. Now, look at negative 2. Eliminate the column and the row, right? So who's left over? 4, negative 2, 5, 6. Does everybody see that? 4, negative 2, 5, 6. Okay? Then I have 3 over here. I'm going to do it over here just so you can see it better. Who's left over? I get rid of the row and column with the 3. Okay, now remember, I showed you right before, I showed you the signs. Notice I didn't put any signs out here. I just put the number with it, right? Okay? Put this number up here. What did we start with? Remember, because it was 1, 1. 1 plus 1 is 2, and negative 1 squared is 1, so this is plus. And then we could go ahead and do our pattern, right? Plus, minus, plus, and that's what we're going to use. So therefore, this is going to be a positive, like B and B. This is minus, and this is a plus, so it'll be minus, minus. And then this is a plus, so I'll do a plus. Yes, ma'am. Right here.
So 1, 1, yeah.
Okay, so remember, this is the location 1, 1. So what you do is you take negative 1 and you add the location. They have this as I and J. What is it? It's just a pattern. Okay. So notice our case, that's 1 plus 1, which is negative 1 squared, which is, if I look here, this is the location 1, 2, so that gives me negative 1. 1 plus 2, which is negative 1 cubed. Does that answer your question? So really, I'll be honest, I would look for this part on the test. I would just make sure you know the pattern. Pattern's really the important part. What would a 4 by 4 look like really quickly? You have plus, minus, plus, minus, minus, plus, minus, plus, plus, minus, plus, minus, minus, plus, minus. Because if you look at the location, this is 1, 1, so that's 2, so that's going to be positive. 1, 1, 2, add them together. Does that make sense? Yeah, because it's always location 1, 1. Does that make sense to you, Rob? All right. Okay, so now let's go ahead and find the determinant of this 2 by 2. It's really simple. Negative 6, negative 6 minus a minus 2, and we're going to times that by 1. So that's negative 6 plus 2, which is negative 4. Negative 4 times 1 is negative 4. Any questions on how minus 2, well, minus a minus becomes a plus because I have a negative result. The determinant here is 24 minus a minus 10. 24 minus 10. So that's a plus. So that's 34. 34 times 2 is 68. Okay? This is a plus 3 times its determinant, which is 4 minus a minus 5. Did you see that? So this is 27. I add those together. Negative 4 plus 68 is 64. 64 plus 27 is 91. Any questions on how I found that number? Yes. Yeah. AB minus BC.
So what's the answer that you can do?
Yes, that's the answer. The determinant of matrix A is 90. All right, now I want to show you it doesn't matter what row or column I pick. We're still going to get it, okay? So, once again, somebody tell me that matrix again. 1, -2, 3, 4, and then 5. Is everybody with me? Let's pick something different. Let's go ahead and pick maybe the second column. Okay? We're going to pick the second column. So, I would have -2, and then I'll put my signs out in front of them in just a second. With the determinant, now we get rid of, remember, the row and the column of that number. So who's left over? 4, -2, 5, 6. Okay, and then I have -1, and it's determinant, so therefore row, column, so I have 1, 3, 5, 6. And then I have 1 with its determinant, which is 1, 3, 4, -2. Anybody have a question on how I have it?
I know it's in minus.
I'll show you.
Okay.
And this one, no. But there is one that you're like, ding, 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 it's showing you which one to pick. No, it doesn't. Now, are there times when you're going to make it easier on yourself? Yes. If there's anything, any row or column that has a 0 in it, use it. Because what's 0 times the determinant? And so I really don't have to do any work there. Does that make sense? So are there times it's going to pull up and say, I'm your man, use me? You know what I mean? Yeah. Does that answer your question? Okay, now once again, I just put the numbers as is. But what should go out in front of the -2? Remember, let's put our sign change here. So that's plus, minus, plus. That's a horrible color, but you get an idea. So this needs to be a negative, a positive, and a negative. Does everybody see that? Understand what I did there? Okay, here we go. Yes. So this is actually going to come out to be 2. No. So 2. Determinant, that's 24 minus a minus 10, so that's 34. 34 times 2 is 68. Okay, and this will be minus, parentheses, 6 minus 15, which is -9 minus -9 times a plus 9. Right? Give me 1 second, I'll come back to it. -1, so that's minus -2 minus 12, so that's -14 with a minus, so that's plus 14. All right, what does that come up to be when I add it? Yes, it's always AD minus B. Okay. Cool, huh? Now, this works only on a 3x3. I just found out today. But I remember being taught this as well. 1, -2, 3, 4, -1, 5, 1, 6. Okay. So I was also taught to, if you notice, we did rows by column, not rows by column, but when we did A, B, C, D, we did this minus this, right? Is agree? So, what I have been taught as well is that you can add these first 2 columns. Just put them up here right next to it. And what you're going to do is you're going to go ahead and add all these. So your forward slashes. You're going to multiply each of them on that row or that slash, and then add all their results. Okay? So here we go. 1 times -1 is -1 times 6 is -6. -2 times -2 is 4 times 5 is 20. 3 plus 4, not plus, times 4 times 1 is 12. Okay, everybody get that? Then what I do is I subtract the backslashes. Okay? Are you playing pool? What's wrong? You miss a day to skip out because you skipped. Where were you at? In where? Mm-hmm. That's called skipping. Yeah. Mm-hmm. And then I'm going to subtract the backward slashes. So notice that's -6. Oh, sorry, that's the wrong way. I just did my forward slashes. So that's -15. 1 times -2 times -1. -2. -2 times 4 is 8. -8 times 6 is -48. So here's what I have. -6 plus 20 plus 12 is 26. Minus -15 minus 2 is -17. Minus 48 is 65. So that's 26 plus 65, which is 91. Okay. Many different ways to show the term. Okay. Agree with me on that? As I was just talking to Joe, I show both ways. The minors and cofactors could be on your test. Yes, but you can even be more specific. Like, for example, on this one, if I had that same matrix again, all right. So they might ask to say M2, 3, right? That's minor. So you know how we expanded a whole column or a whole row? Well, this one, I just want to know there's a little p using that element. So notice the element 2, 3, right here. Everybody with me on that? So I have the number -2. So then once again, we eliminate the row and column that it's within. Row, column, so that's 1, -2, 5, 1. Okay. So then this would be 1 minus a minus 10. Okay, which is 11. With that -2 out there, but what number should be out in front of that as well? Because this is, once again, plus, minus, plus, minus, plus, minus. So this should also be a negative. So negative makes it a +2. So 2 times 11 would be 22. So the minor of that is just. Okay, so they might ask you a specific part of your expansion of it. With me? Mm-hmm. Yes, no? All right. I'm going to take a little drink of water. I'm out. You weren't here either. You guys were all having a fun day in East Shore. No, where were you? Sick? Huh? I'll let you slide one. Okay. So, we're going to go on to Kramer's rule. Okay. What Kramer's rule does is it takes an equation. I would make sure you're up and about for this one. You're great, Amish. I love you, but I just want to help you. Let's say we have this equation. Okay? Let's go ahead and write it as a matrix equation first. Okay? What would this be as our matrix equation? We've done this a past couple times. It's just another matrix. Whatever. All right. So what Kramer's rule tells us to do is it says, if we call this matrix A, okay, find the determinant of matrix A, or once again, it would look like this. Okay? Let me hurry and show you through what it is, and then we'll come back and do the formula. Ready up? So the first thing, let's find the determinant of matrix A. 2, 6, 1, 8. What do we get there? 16 minus 6, right? Which is 10. Everybody there with me? Now what Kramer's rule tells us to do is, I'm going to denote it as the determinant of AX. Now what that means is you replace, okay, the X column. Who's my X column in that matrix that I have? Who's my X column? 2 and 1, right? Because wasn't this 2x plus 6y and x plus 8y, right? So this is my X column. I'm going to replace my X column with the answers. Who is my answer? Negative 1 and 2? Is that what that? Right there? Okay. So I replace my X and my X column with the answers, and I do my determinant. Once again, the determinant would be negative 8 minus 12, which is negative 1. No, because I went ahead and just kept this matrix, right? Our regular basic matrix, and I replaced the X column with the answer. So therefore, 6 and 8 are still there. Does that answer your question? Is it okay? Ready on this one? Okay. Now, I'm going to hurry and find AY. We okay? Thanks for speaking in English. Meaning, I said something in mathematicals, and you spoke in English, right? Okay, so this time, because I'm looking for Y, guess what I'm going to do? I'm going to put the answers instead of the X column. I'm going to put it this time in the Y column. So that, nope, so therefore this time it's going to be 2, 1, negative 1, 2. You see how I replaced the answers and I plugged them in the Y column? Yes? And we find that determinant, which is 4 minus 1, which is 5. So what Kramer found out is that X is equal to determinant of AX over determinant of A. Who was determinant of AX? What number did we get? And A? So what is X? Okay. What do you guys think Y is then? AY over the determinant of A is negative 5, or just negative 5, over 10, which is regular half. So Y is a half. Can we go back up into our system and check it? Okay, let's go back into our system and check it. Okay, who was X did we find out to be? Negative 2. Y was a half, right? Negative 2 times 2, negative 4. A half times 3. Oh, excuse me, I gave you the answer. 6 times a half, 3, so negative 4 plus 3 is negative 1. Let's check it down here. Negative 2, a half, times 8, 4, negative 2 plus 4. Cool, huh? So that is, once again, the fifth way to solve a system of equations that are in standard form. If you have pink eyelashes up, you pull out. Okay. Maybe so too. Yeah. 3 by 3? You do it with a 4 by 4. Okay, and we're going to do that next. And I'm going to show you the one that they have in the book, why maybe it's a good idea sometimes to use Cramer's rule. Because in each situation could be, hey, this situation it might just be easier to do elimination because if I was out in the real world doing our own math and choosing whatever way we want to solve it, yeah, one way might be easier. And another way might have its reasons why I might want to use it, right? Does that make sense? So, but on the next one, okay, here's the equation that we have. So again? Yeah. Spritting. Getting the oils. This is like a natural fragrance in my room. It's like somebody has BO. The orangey flavor. Are we all caught up? We ready to rock? All right. So let's just start off and say our basic matrix. Who is our basic matrix? Who's he going to be? 2, negative 3, 4, 1, 0, 6, 3, negative 2, 0. We're going to find the determinant. We're going to just call that matrix B. We're going to find the determinant of that. Now remember, it doesn't matter which row or column. So there's 2 of them right there saying, hi, it's me. Which one do you think he is? Which ones are saying, I want you to pick me? Row 2 or column 1 or row 3 or column 3. Now I personally, row 2, column 2, hi. Hey, whoa, hey, well, you can't do that. You want to? You need me? I'll let these guys. Okay. So dx would be 1, 0, 5, negative 3, 0, negative 2, 4, 6, 0. Find the determinant. Is there a column or a row saying, pick me? Pick me? Which one is? Because it's staring right at you. The 0, 0, 6, huh? Okay, now you guys find that. Yeah, dy. Okay, dy is there a specific row telling us to pick me? Maybe not. I mean, there's a couple options. I have row 2, column 2, row 3, or column 3, right? But I have some options there, don't I? Okay, and then for you guys, dz would be 2, negative 3, 1, 1, 0, 0, 3, negative 2, 5. You guys also have a row saying, pick me, right? Because it's 1, 0, 0. Obviously, I'd pick that row. Do you guys understand why I do that? Yeah? On the test, they might ask you a specific way, though, right? Well, meaning, oh, what did you just say? Sorry.
Like, one minute.
Oh, are you asking me to solve the just an equation or taking a row? That's exactly. Say your question one more time. Let's start all over.
I felt that I could, that's the problem,
Okay, and you're more than welcome to do that, but once again, on the test, it might ask you to do it with both factors. That's for no, you gotta take a row. All right, let's go over here, dx. My dx people. You guys used this column, didn't you? I mean that row. Correct? And it makes sense to use that because notice first off, plus, so this is minus, plus, minus, so I have negative 6. Okay? Which gives me 1, negative 3, 5, negative 2. Correct? Is everybody there with me? So that's negative 2 minus a minus 15 times by negative 6. So that is 13 times negative 6, and that's on that negative 78. You guys get that? Did you try it? Very good. You have one of these people? Did you do it? That's the reason. Did you do it? Did you do it? Let's see. All right, I'll let you go. Did you do it? Okay, at least you tried. Did you do it? Good, good, good. I'm coming around second shot. Did you do it? All right. Dot to shames, people. So have you ever did a dot of shame?
I never heard of it.
Well, I tell you what, it's a fun thing for me at least. Now the rule is they can't erase it. Because what happens when you erase it? Because it's mathematical, it grows exponentially by powers of 2. So then hence it's in a math class, so it's legal. Okay, now, which one did you guys pick? Anybody pick a specific row or column? Tell me. You picked this one? Did anybody pick this column? You did? Okay, I'm going to do the column just for the fact that we haven't done the second column really yet. And notice this is negative plus negative. Okay, so therefore I have negative 1. Get rid of the row and the column. So I have 1, 6, 3, 0, minus 5. I'm left with 2, 4, 1, 6. Okay? So I get negative 1, 0 minus 18. So that just comes out to be 18, doesn't it? And then this guy's minus 5 times 12 minus 4, which is 8, which is negative 40. 18 minus 40 is negative 22. Did you guys get that? What'd you get? Is it supposed to be positive? Did I make a mistake? Nope, I got negative. It says negative in the book too. Okay. Zers. Okay, Zers. Ladies. Okay, say your question one more time. I put these 2 columns right next to you. So read it to me again. Your X, your Y, so you should have
1, 4, 1, 0, 3, 5,
all right, so then here's your original. So if you're doing this, I would, once again, this is good, but don't just rely upon this, which you are.
I just tried it
All right, here we go. So you would go 0 plus 18
out.
plus 20, so right there, that's 38. Because I added all those columns, right? Then 0, 60, 0. So then that's minus 60, which is negative 25. Okay. With me there?
Yeah.
All right. DC. Which row and column did you pick, Chancellor? I bet I would pick row 2 myself, right there, because that's the pretty one, right? Now, what's the total? What's the number out in front of 1? Should I have it as a plus or a minus? Negative. So therefore, negative 1. Get rid of row and column. So I have negative 3, 1, negative 2, 5. Which is negative 1 times negative 15 minus a minus 2. Which is negative 13 times negative 1, which comes out to be 13. You guys find that same result? Can you guys not do it? All right, I like you all. See, Tweedledee and Tweedledum over here. Okay. Last thing. Now, how do we use that information? Well, remember, x is dx over d, right? Who was dx? What was your guys' result? Negative 78, right? Over, I think, d was, what was d again? Negative 38. When I reduce that, okay, when I reduce that down, that gives me 3919. Imagine having an answer when you're doing reduced row echelon form and having 3819. Right? You guys remember like doing rows by rows and dividing and adding? What do you guys really want to play with those nasty facts? Was it as bad doing it this way? No, pretty simple, right? So is there benefits in each style? Yeah, sure. Okay. Once again, what's y? dy over d. Right? What is dy? Negative 22 over negative 38, which is 1119. Okay? And then z is dz over d. dz was 13 over negative 38, which is negative 13 over 38. Okay? So we were able to solve that system of equations that even came out nasty answers and not too hard of a situation. Okay? That's I would say 7/8 of our lesson. We got one more thing to talk about. Okay. The last thing that can come about with determinants is finding area of a triangle. Does anybody remember what the area of a triangle is?
1/3.
Nope.
1.
Base times height. So I'm going to show us a triangle that's really simple on the xy axis. Let's say we had 0, 0, 0, 4, 5, 0. We could do the area of this triangle really easily without having to do a lot of work, right? Who's my base? How big is my base? 5. How much is my height? 4. 4 times 5 is 20. Cut that in half. The area of this is 10 units squared. Right? Now, are all of our triangles nice on the x and y axis? No. If you went back like when I taught secondary 2 last year, those kids had to find the area by finding the height, finding the base length, and all that stuff. That wasn't very fun for some. Okay? So let's show you an easier method. What they do is, let's just assume the formula is you take your 3 points. Let's say we have x1, y1, x2, y2, x3, y3, because all three, there's usually 3 vertices of that triangle. Right? They all have xy coordinates. That's what this is. Well, remember, the only time I can do a determinant is in what kind of matrix you square. But I have 3 inputs. That's a 2 by 3. excuse me, a 3x2. Is that a square matrix? So what you have to do is add 1, 1, 1. And when I was kind of asking Joe this a little earlier, but I was talking, I was thinking about putting them all in the same Z plane. Because remember, planes are, like this is a plane, that wall is a plane, this wall is a plane, right? A plane is a collection of three or more together. So they needed to have something so that became a square matrix. Now, they have to do plus or minus a half. Now, the reason why the plus or minus is here is because the determinants come out always positive. They always come out positive. Did we, on our last example, have all positive determinants? Yeah. Right? So therefore, what if our determinant was negative? Then we use the negative a half. Because then area is always positive, isn't it? So if it came out negative, then I'd use the negative. If it came out positive, I'd use the positive. Does that make sense on why it's plus or minus? Whatever sign I needed to get you back to a positive result. Okay, so let's use these points that I have here. Okay, our points were 0, 4, 1, 0, 0, 1, 5, 0, 1. Let's find the determinant and do plus or minus. I use the points that I have. Remember the points I used was 0, 0, 0, 4, and 5, 0. Those were the points on my triangle, right? And then the 1, 1, 1 is part of the equation. Is there something saying, pick me, pick me? No. First or second, I'm going to use actually second row because it has a 1 in it, and then I'll have to times everything else. Okay, once again, using this is negative plus negative, right? Okay? Abby, you still with me? I'm kind of zoning. Yeah. I know it's hard sometimes. Not a lot. Okay, negative 1. Get rid of the row and the column. So I have 0, 4, 5, 0. Notice I get 0 minus 20, which is negative 20. Times by that negative 1 is 20. So do I need to use the plus or the minus the half? Because it's already positive, I'm going to use times by the plus a half to give me 10. Now, obviously, if it was that nice of a triangle, I probably would have used it, right? Because I can put this in the base of the height. But not all triangles are really nice. Would you like me to show you one? So, let's make this up. Let's go ahead and have the point 1, 2, 5, 4, 10, negative 2. Okay? So here's my triangle. Once again, not easy to see the base and the height of that triangle, correct? You guys agree with that? But I can quickly put it in my matrix. 1, 2, 1. 5, 4, 1. 10, negative 2, 1. Find the determinant, plus or minus a half. Is this one somebody calling out to me saying, first row, or I would pick the third column. Okay? I would personally pick this third column. And notice with that, this is plus, minus, plus. Everybody good with me? Okay, here we go. So I have 1. If I get row and column, I have 5, 4, 10, negative 2. Negative 1, 1, 2, 10, negative 2, plus 1, 1, 2, 5, 4. Here we go. So all these are just out there. So this is negative 10 minus 40, which is negative 50, minus negative 2 minus 20, negative 22 times negative 1 makes it a plus 22. 4 minus 10. Stick with me, guys. Okay, 4 minus 10 is negative 6. With that 1 is negative 6. Okay, so that gives me negative 34. So in this case, am I going to use the plus or the minus a half? We're going to use negative a half, which is 17 units. Okay? Now, once again, a lot of this can be done via calculator, but we don't get used to that. Okay? Yes. Yes. And make it so it's a 3/6. 5 through 47 odd plus 57, ladies and gentlemen.
Good.
Hmm.